Hello everyone. This is an educational poster to help you understand the basics of green research software engineering and help you identify the areas where each one of us could contribute to building cleaner and greener software. So, a lot of you might already be knowing that carbon emissions is basically carbon getting released in the atmosphere when you use any fossil fuel powered equipment or process. But not all emissions are under your control. So we begin with identifying emissions that are directly onto you to control and which ones are coming from, say, your partners and are not directly your responsibility. Hence, you will learn a little bit about scope of emissions in the poster. Next is having a framework that could help us drive the process of developing green software. So there's a framework called the Greener framework that I have mentioned in the poster, which has principles like high-level policy making, identifying individual responsibility, estimating emissions, etc., that can be followed to begin your green software journey. Then there are a few metrics that you could learn about that would help you structure and quantify the emissions better. For example, there are metrics that are more suitable at software level, like the software carbon intensity, and at hardware level, it could be your CPU and GPU utilization percentage, etc. Similarly, in the end, there are a set of Python packages and web calculators that I have mentioned that you could use to quantify your emissions. There is also a Green Software Foundation course that you can go through to have a more in depth understanding of green RSE related concepts. And if you have any questions or comments, I will be available online. And thank you for listening. Thank you.
All right, that one was perfectly in time, and we'll now continue with the in-person presentators. And first up, we've got the Journal of Open Source Software. Mr. Forward.
Hello. So the Journal of Open Source Software, which you may already know, known as JOSS, is a developer-friendly journal, publishes short articles about research software that is in some sense substantial. If you want to know the details of what we mean by substantial, come and chat to me at any point. So I'm Warwick. I'm one of the associate editors in chief, so I handle one of the kind of subject areas that we get submissions in. At the conference as well, Dan Katz is here, who handles computer science, information science, mathematics. I'm astrophysics, astronomy, and space science myself. There's 8 of us assistant editors-in-chief. We have our esteemed editor-in-chief, Alphonse Smith, who I think was at RSECon last year. And then we also have a community of about 100, that's just shy of 100 volunteer editors, a few of whom are here. So I know Jack Atkinson is around, and Richard Littauer is around as well. I don't know if there are any other JOSS editors in the room I haven't mentioned. Okay, got them all. That's great. So if you're interested in submitting to JOSS, come and chat to me at post number 5. If you're interested in reviewing for JOSS, then you come and chat as well, or register yourself on our reviewer database, which is always tremendously useful. It's the first place we look for reviewers for the submissions that we receive. And we also have an open call at the moment for additional editors. So if you're interested in applying to potentially be an editor for JOSS, come and chat to me as well, or you can find the link in the JOSS blog. The submissions close on Monday, I think, September 15th, yes. So if any of that's of interest to you, come and chat to me, post to 5, or anywhere else that you see me, be that coffee breaks, lunch, breakfast, dinner, whatever. Thank you.
Thank you so much. Just remember if you have multiple slides, feel free to take the presentation stick thing. And next up, we have It's Time to Decarbonise Digital Research.
Hello. Yeah, thank you. So yeah, my name is Kirsty Pringle. I work for the Sustainability Institute. So this poster, it's the first time I've ever done a poster. It's really just my opinion. So we'll see how that goes. But I've been speaking to a lot of people about the path to net zero and how we as research software engineers, wider as researchers, people working within digital research of any kind, can get to net zero. How can we reduce the environmental impact of the research we do? And it seems that we're at this kind of interesting point where we know that research is essential for society. Research does so many good things, but we need to make sure we're doing research in a way that minimizes the environmental footprint of that research. And the vast majority of people I talk to about this are super keen to do something. They want to help, they want to make sure that the research they're doing, the software engineering they're doing, has the smallest environmental footprint possible. But there's not really a pathway, there's not really that much guidance about what we can do. So yes, I want to make the right choices. How can we do that? What can we do? And so I wrote a piece for Research Professional News, which says, it's time to decarbonise digital research. And it was really about this, the fact that there's a bit of a gap in terms of giving people a roadmap to follow. So on my poster, I've got a couple of projects. We've got the Green RSE Special Interest Group, we've got the Green Disc certification, we also have the NetDrive project, which are 3 projects which are all trying to help researchers, people working across digital research, to try and kind of give them some direction as to how they could potentially help to kind of reduce the environmental impact of the research. Thank you.
Next up, fair tool for research software.
There's growing recognition that research software should meet the FAIR principles for research software, as well as broader open research practices such as reproducibility. However, the people who are writing research software, researchers, often lack software development skills through lack of training. And to fill this training gap, at the University of Sheffield, we have developed a programme for FAIR and reproducible research software skills. It's a modular programme that covers the research software lifecycle from planning through coding best practice, reproducibility tools and publishing. It's a modular programme which allows individuals to choose the different components that fit their learning needs. And my poster talks about the impacts, challenges, and lessons learned from the first year of delivery of the programme. Thank you.
On with developing the enCore community land model.
Hi, my name is Rigor. I'm representing the terrestrial modeling group in Jülich Research Center in Germany. And I wanted to share with you the software stack that we use for climate simulations. So our group does regional climate simulation. So that means from geoscientific phenomena from subsurface through the land surface until the atmosphere. Continental scale, no ocean, unfortunately, at least 12-kilometer resolution. So we developed a software called Terrestrial Systems Modeling Platform, and the land surface component is a bit outdated. So my poster focuses on the land surface component. And just to zoom in into this land surface, it's a bit, you see this complicated diagram, so it kind of reflects the complexity of what's going on in the land surface. And basically my poster is about how we took a battle-tested land surface model called Community Land Model 5, developed in the US. We did some heavy refactoring and took just a computational core and kind of changed something about the helper and the build system too. So if you're interested, you can go into my poster to know more details. And yeah, finally, as much as I wanted this to be a prototype, it's already on the wild. A lot of PhD and postdocs in our group are already using this. And yeah, so yeah, thanks so much. Poster number 35.
All right. Moving on with bridging bench and codes, RSEs driving Omics.
So in life sciences, at the minute, modern sequencing turns DNA into terabytes of data, and these data sets are huge, complex, and essential for understanding health and diseases. So what is needed? Robust pipeline, efficient workflow, and integrative tools. But we have data is too large, software changes fast, and genetic information is layered. I think that RSEs, by combining software development, data manipulation, and domain insight, domain-specific insight, they can drive omics, not just support it.
Right. Please welcome enabling research software excellence for RSE community conversation.
Hi everyone. I hope you have been having a good experience at the conference so far. I'm Jyoti Bhogal. I am an SSI Fellow 2025 and I'm the co-founder of RSE Asia Association. So, and I'm very thankful to have this opportunity to speak about this event that we organized. So this is about enabling research software excellence through RSE Community Conversation Series, and it was a collaboration between African and Asian RSE communities. So we launched this last year on the International RSE Day in October, and it was a 6-month-long online panel and it was a community conversation series jointly organized by RSSE Africa and RSE Asia Association. The episodes touched upon different topics that RSEs in Asian and African regions touch upon in their day-to-day work. This included software reproducibility, testing, documentation, and also raising funds for research software work. It has been quite a popular series with about 200 registrations for each of the episodes. And also for every episode, at the end of the episode, we created a lot of materials that we shared openly. We had, you can scan the QR code, which will take you to the materials that we have shared. We have created summary blogs for each episode. We have collated learning resources which are shared openly on Zenodo, and we also have YouTube recordings for each of the episodes. So please go ahead and check that out. If you I feel that the success of this event was due to the intentionality that we put into the planning. So if you are interested in organizing something similar, or if you want to collaborate with us or just chat about it, please come and find me over at poster number 61. At the end, I want to thank you all for listening in, and I also want to thank the team and the reviewers for my poster, which include Enelda, Saranjit, Mirel, and Jost. Thank you, everyone.
Next, we'll learn about reimagining digital accessibility.
Doing work on publicly facing websites to make sure that they meet digital accessibility guidelines. It's like cleaning your bathroom toilet, mowing the lawn, doing the dishes. It's tedious, repetitive work. Nobody likes it. Nobody really wants to do it. You do it once and then it needs doing again shortly afterwards. It's hardly surprising that in the past, KDL took rather a negative attitude to this work. We felt that it was an activity that was forced on us for compliance means. We pushed all the onus for doing the work onto the design team because, hey, accessibility design, that's their province, right? Everyone else could safely ignore it. We did it in a haphazard manner. We didn't integrate it with our software development life cycle. It was a massive pain in the ass, to be honest. But come and see this poster and it'll tell you about all the changes we made to now have a fully proactive approach to digital accessibility. You'll find out how, for example, we split the responsibility among team roles so that everybody has a share in it, everybody knows what to do. It's not just on the design team, and it's much better, more equally shared. We found a system for prioritizing work. What kind of DA work should be done on what kind of project? And most importantly, we came up with a comprehensive set of steps that are fully integrated into our software development lifecycle at all project stages. And we have, you'll see a comparison between how it used to be, how it is now, and you'll see also an assessment of the impact that those changes have made. So if you're suffering in the digital accessibility doldrums, come and see our poster. We'll send you a way out.
Learned a lot. And next we have developing the Go-to telescope control system.
Hello, I'm Martin Dyer. I'm another member of the RSE team at Sheffield. So I only joined the team relatively recently, but for the past 10 years, I've been working on this as my main research project. So this is the Gravitational Wave Optical Transit Observer. It's a network of robotic telescopes we operate around the world. It's a partnership with various universities and institutes, including Sheffield and the University of Warwick. My main job as the chair of the technical working group is to develop the control system and scheduling system for our network of telescopes. So yeah, if you're interested in hardware control, infrastructure, scheduling, also some of the work I've been doing as chair of the working group to kind of introduce best practices and things within the collaboration, or if you just want to come and look at some pretty pictures of space and galaxies, then come and check out my poster. Thank you.
Much on OLS.
Thank you. Hi everyone. Sorry, I cannot complete with those images.
My name is Sara Villa. I'm the training and community lead for OLS. For those who don't know what OLS is, it's a non-for-profit organization. We really believe in open science, and we are dedicated to capacity building and to leadership diversification. We work under 3 different pillars or ways of working. So we have a open science training and mentoring program. We also do our own open research, and we are currently going spearhead with our open incubator. So I'm here because I hope I don't need to convince you of how important open science is, though we can talk about it over a coffee later. Of course, getting some of open science skills is quite easy, but managing over a whole project is not that easy at all. And we have found that over our Open Seeds mentoring program. So we are now over 300 projects and just managing the outputs of those projects, the participants and the responsibles for those projects, and all the resources that we get through this training. It's quite burdensome and quite difficult to do it in an open way. And that's why part of our team, mainly Berenice Batut and Deborah Udo, who's around here, also volunteering for the conference, came with this knowledge management system. So it's literally been a catalyst for collaborative knowledge management. This system relies on open technology stack, powered by mainly Python scripts and maintained on GitHub. I'm not powered enough to actually explain this technically, but we also have Riva from our OLS team around in the conference, so feel free to bother any of us if you want further explanations about this. Thank you so much.
All right, next up, Drift.
Hello, my name is Laura. I work at EPCC at the University of Edinburgh, and I'm here with a poster about a project that I work on called Drift. Other members of Drift work at Imperial College London and also at the University of Oxford. If you were just in the track B, you'll be sick of the sight of our logo. So the aim of Drift is to address the lack of DRI focused training for research support roles. And it's also to try and raise visibility of DRI outside of physical sciences and engineering. We've got a bunch of work streams working on it. 2 of them were in track B. The Gutenberg training platform from the University of Oxford is being supported by Drift. And we're also working on developing a project management curriculum, which is focused specifically on project management within RSE teams. And then the work streams that weren't in track B are looking at what are the needs of people who work in research support roles, what is research facilitation, and how do aspects of that come up in other roles that are not explicitly called research facilitators. And we've also got a community aspect, so we're trying to look at what do the community need, and we're also building some mini HPC clusters to help us bring like what is HPC out to people who might not have seen it. As well as giving you all this information, we would really like some information back. This project only started in January, so we do really need help from the community to let us know what you need. So if you could scan the QR code and come to the poster and let us know what would be useful, that would be great. The survey does cover all of the work streams, so hopefully there's something for everybody in there. Thank you.
Great. The next speaker will tell us about leveraging GitHub API data.
Hello, my name's Dan. As I said, like all the best ideas, this one started in the pub last year during RSECon. As you do, we were discussing how do you track the real world usage of GitHub and Git after training. And my former Sheffield RSE, Anna Cristalli, said, well, we've got this whole training thing that we've been running for the last decade or so. And as part of it, the trainees submit a pull request to a single repository to get them to learn how to do that. Can we look at that? And so that's what I did. We've got about 395 participants. And I looked at how many trainees have limited usage, so how many people registered within 30 days of the, on GitHub within 30 days of the training, how many have registered before that but don't show any activity, how many of these trainees show activity within 1 year post-training, and if you have prior GitHub activity, does it increase after you do the training? Do you get more confident, to get happier? I'm not going to tell you anything about that now. You have to come and see me at the poster to find out what I found. Thank you very much.
There we go. Auto emulate.
Hi everyone, my name's Edwin. I'm part of the Auto Emulate team based at the Alan Turing Institute. So many of you in this room may contribute to software that attempts to simulate the real world. And you're probably painfully aware the real world is complicated. So often those simulations can take very long to run. It could be days, it could be weeks, it could be months. And maybe you don't have time for that. In which case you can sub that out with an emulator or a surrogate model. So this is a statistical model that can replace this process. And often these run, or they usually run a lot quicker. Auto Emulate is an open source Python package that we've been developing that tries to make that process a lot quicker. So you don't have to worry too much about the machine learning processes. It aims to try and build a emulator much more easily for you. And then it has lots of downstream features, which you'll have to come to the poster to find out. So thank you very much.
I did just spoil it.
Hi everyone, my name's Tom Roberts. My poster today is about PyOnB, which is the open source optical character recognition toolkit for document to text conversion. So just to give you a bit of context on that, this project came out of medical research projects at UCL in the MS Pinpoint team. They do research into multiple sclerosis. At the hospital, we recently transitioned to a patient system called EPIC, which is a modern patient system that was put in about 5 years ago. That records patient data in very nicely formatted structured records. But because multiple sclerosis is a chronic longitudinal illness, there can often be data that goes over a period of, say, 20 years or something like that. That data is stored in another database called Highland OnBase, which gives the name of the software, PyOnB, Python OnBase. Sorry, it's tentative. But that data has been untapped for decades, and it's also sitting there stored in PDFs and JPEGs, which is very hard for the researchers in the MS Pinpoint team to actually use. So they need plain text. Come in all of these beautiful, handsome people across UCLH and UCL. And we have put together something called PyOnB, which is an open source Python-based application, where we are taking lots of new and modern OCR tools, which have sort of popped up around the internet. There's many of them nowadays with the advent of LLMs and things like that. We've Docker containerized them, stuck APIs around them, and then deployed this on our UCL and UCLH, the hospital and university infrastructure to take those documents, form optical character recognition, and output plain text. So if you're interested in hospital deployments, if you're interested in optical character recognition, not necessarily for hospital applications, and even medical devices, which is also my field now, come and chat to me at the poster. Thank you.
Right, it's wonderfully in time. So next up, optimizing CACWare.
Hi everyone, I'm Phil from the University of York, RSE team lead, and the co-author on this poster is Maciek, who has been our intern for the past year. And this poster is about a project that we worked on together, actually Maciek's first project, which was deploying and customizing Kirko app. Now, Kirko app is an open source Python web app, which acts as a nice searchable front-end interface for Zotero, bibliographic libraries. And we've now got 4 instances of this deployed at York. So the poster talks about why people like it, some of the features and functionality of Kirko app, also how we deployed it and customized it. But the second part is also about the kind of intern experience that Maciek had, the process he went through, kind of the useful things he's learned along the way, including lots of the technologies that are shown on the slide, and also from my perspective as well, managing it. And we both think it was a really kind of successful project. So if you want to learn a bit about Kirko app, or also learn about the kind of internship process and how successful it can be, then please come along and talk to us. Thank you.
Right, it's getting towards the end. We have intermediate research software development lesson.
Hi everyone. Yes, so my poster is about this intermediate research software development lesson that is in the Carpentries incubator, open for you to freely use and deliver. Start with the premise that we shouldn't believe all of the AI hype, and that we as a profession will need to still have some software development and engineering skills, and particularly at the sort of intermediate and above level. So the things that this course covers are software environment and the tooling needed for setting that up in your research software, automated and scaled testing of your software, requirements collection, software architecture and design, collaboration, and then publishing of packages to get your software out there, and finally finishing off with a bit of project management. So some decent overlap with one of the previous courses that was delivered beforehand. Some of the nice advantages of ours, you can pick between two editors. We're making this more seamless, but at the moment it is definitely possible to go through with either PyCharm or VS Code. There are multiple different delivery styles that are possible. So in the sort of typical carpentry style of having instructor-led, but also there is study groups. So you can split learners off into smaller groups. They then rejoin at various points through the course, and that is sort of coordinated by a central instructor. And of course, there is the potential to do this independently on your own, and the content's very amenable to that as well. Finally, I want to finish on our approach to how software design is taught. I think it's a really novel and quite nice way to do it. We take a existing software project, identify some problems with it, do the refactoring, and then kind of get to the theory and why that was actually a good way to go about it after. There's a QR code there, and I didn't see anything in the code of contact about bribery. I have some pins if you come to my poster and vote for me, so I'll give those to you. Thanks.
All right, let's go PyCharm. PR Max.
Hi, I'm Nathan. I'm working at EPCC. I'm presenting some work here to add MPI to GPR Max. So GPR Max is an open source Python code base with performance critical parts written in Cython. It was originally developed to model ground penetrating radar. However, it's got a lot of applications anywhere where you want to model the propagation of electromagnetic waves. Prior to this project, simulations could run on the CPU solver using OpenMP parallelization or a GPU solver using CUDA. However, in both of these cases, models were limited to those that could fit within the memory of a single node or device. This restricts how many resources of a HPC system you can use, and limits the size of models that researchers could run. So the work presented in this poster adds MPI domain decomposition to the CPU solver, and this allows models to be divided across MPI ranks, enabling researchers to run much larger simulations and to explore new science. So our benchmarking runs on Archer 2, demonstrates an immediate speed up when running on a single node, as well as very good node scaling performance, but I've got much more details on that at my actual poster. So other results from the project include a new regression testing framework designed for HPC using Reframe as a test harness, as well as support for parallel I/O for simulation and visualization outputs. So if you're interested in electromagnetic simulation, using Python at scale or any of the software engineering behind it, then I'd be very happy, or anything else I mentioned, I'd be very happy to talk to you on my poster later. Thank you.
Here. Next up, we have our playwright.
Hello, everyone. My name is Erica, and I'm a PhD student at the University of Sheffield. And I would like to introduce you to our playwright, which is an art package that I developed during my participation at our OpenSci Champion program in 2024. And it's basically an art package that wrap Node.js playwright capability. So as a user, we can access that through within our environment. And the idea to build this package came from my own experience when I have to deal with JavaScript heavy web page, and I ended up using Playwright, and I found it super useful to solve my issue. And as an R user, I wish that there is a way to use the same capability within our environment. And at the same time, our OpenSci opened an application for package development mentorship. So I applied for that, and how it all started actually. And technically it's built using RSEC API that imitate Playwright structure. And under the hood, it runs Node.js backend, and it runs browser engine like Chromium, so we can have browser capabilities from within our environment. And how to use it. So actually I provide 3 examples which I included in my poster. So please come visit my poster to see the examples of how it can be used. As a disclaimer, this is still in a development stage right now. So far, I managed to cover around 25% of all the classes that are available in the original Node.js Playwright. So there's still lots of work to do, and there's still lots of room for improvement. So I also would like to invite you to collaborate and maybe submit an issue if it's possible. So yeah, please visit my poster and we can talk about it more later. Thank you very much.
About impactful scientific visualizations.
Great, thank you. Yeah, so on this board, you see lots of different visualization from different fields. You have fluid dynamic, you have one in the middle that you may remember from Nathan just now. You have some molecular dynamic as well. And so these visualizations are useful like for outreach purposes, for like reaching like a broader audience to your field, your domain. And like the main thing they have in common, besides, yeah, I've done another way. The main thing they have in common is that they've all been done using Blender. Blender is a 3D open source toolbox that like mostly is used in the VFX or 3D animation industries. You have full movies made with Blender now. But it's used more and more for the scientific community as well to do this kind of visualization. And so today, I'm mostly talking about a tool. Yes, a tool called Blender Remote Render, or because yeah, I'm really good with acronyms. So it's a tool that uses Blender, but more for that is more sort of in line with how we work usually. So we often only have like thin laptops, but we have access to HPC large systems with lots of nodes and everything. And so the idea is that you can use your small laptop to design your scene and do all of the first work, and then it works as a client-server kind of approach. You have a Blender add-on on your laptop, on your client, and you can directly connect to an HPC, and it will submit a job for you and run Blender in that job, and then you can get back the final images. So it's a way to make Blender a bit more targeted to our world of research. So yeah, feel free to come to my poster. I have more visualization over there. And if you want to talk to me about this tool in particular, or about Blender in general, about scientific visualization, feel free to talk to me. I'm always happy to talk about that. Thanks.
Right.
Hi, I'm Colin. I'm a senior RSE at the National Oceanography Centre, and I'm one of the co-authors of CATS, the Climate Aware Task Scheduler. Also in the room, we have Warwick and Sadie. I'm not sure if he's here. Abhishek and possibly Tibble, who also worked on this originally. So if you do see any of us, please come and ask us about CATS and have a look at our poster. Just a bit of our inspiration behind this is that most of us are in this situation where we're happily doing our computational work and the world is slowly catching fire and burning behind us, and we're adding to that problem by burning fossil fuels to produce electricity that run our computers. And we would like to try and do something about this, or at least reduce our impact upon this. And it's good to have seen quite a few other talks so far on the sort of green RSE theme, and that we're not the only people trying to solve this problem, and we are not purporting to solve the whole problem. But at the Collaborations Workshop Hack Day in 2023, we came up with the idea of building something that would time shift when compute jobs are run to when the grid energy is less carbon intensive. So in this country in particular, we have huge variations in the amount of carbon dioxide that is put out by our electricity production, depending on the weather. If it is windy and it is sunny, we have very, very green, very low carbon electricity. If it is not sunny and it is not windy, it is pretty bad still, because we basically burn gas to make up the difference. And fortunately, the National Grid have provided us with an API that tells us what the carbon intensity of the grid is going to be with a 48-hour forecast. So CATS uses this data to figure out when we should run our jobs. We have to tell it approximately how long the job will take, and CATS then figures out when is the best time to go and run that job. You also have to tell it the approximate region you're in. So if you give it the first part of your postcode, it can localize you and figure out what region you're in, and therefore minimize the carbon intensity of your job. When we first wrote this, we only wrote it for the very classical and I think seldom used AT scheduler that is shared with most Unix systems, but I had never used certainly until that point. But since then, we've actually had some additional follow-on funding from the Software Sustainability Institute to make this work with Slurm. And we now have a basic version that works with Slurm. We would say there is one major caveat to CATS is this does not work if your system is 100% load. You can't time shift your job because someone else's job will just fill the gap. This only works really on systems that are not 100% busy. So this is probably best suited to smaller HPCs or sort of departmental systems or smaller servers that you may have in your area.
Right, do we have any more? I think not. Okay, probably use the time slot. Then thank you everyone for taking a look at those 90 slides, and make sure to stop by their posters in the poster session, which is just right up the staircase. Thank you so much.